So then it becomes 1 centimeter is equal to, we have a 2.5 kilometers, and then when you talk about 1 centimeter in 50,000 is 500 meters, and 2.5 kilometer in case of that. So that means according to the scale, your accuracy also, and then error incorporated also, it changes. And then, as I mentioned earlier, density of observation also plays an important role. The more density, then more accurate, but at the same time, you are affecting the cost. So cost may increase that. And then what is the format to use, and then accessibility, etc. And then cost. So all these things plays a role. Format, if you take in one format, try to put it in another format, and then when you change from that format to another format, so it also creates a problem, creates error for that. The second component of errors is sources of errors in GIS database. So errors resulting from natural variation. So with the natural variation, you draw a line. If it is fuzzy in nature, whatever you draw a line, some other person draw the line, maybe you may not put exactly at the same location. So that means positional accuracy is going to affect it. And then accuracy of the content, either it is a qualitative or quantitative content. Suppose you take a groundwater, these things, you say so that thing it is a good quality. Good quality means what? How much good it is. It is a bad quality, you say that. That means you talk about in terms of qualitative terms. So sometimes we say that it is highly suitable, suitable and less suitable. So and then whatever you say highly suitable in your case, say same thing for other person, it is moderately suitable. So then these are also create errors for us. And another thing is natural variation and observed bias. Natural variations is, suppose as I mentioned that boundary of the river and then soil features, all those things. So that is due to the natural variations, you may get errors, but they are not basically errors. Another third type of errors is errors arise through processing. So when you say that, as I said, GPS, earlier I mentioned, if the GPS can measure up to 10 meter or 1/10 of the meter, and then it can be 100 meters. So according to that type of these things, your errors will be differ. And another thing is you apply a false overlays and misuse of the logic. So that also affects. Errors are also classification and generalization. As I mentioned also earlier, you do more generalization, so more error you are getting into that. So quality is, we talked about errors, and then now we are talking about data quality. Quality is basically a function of intangible properties such as completeness and consistency. So let us talk about what is completeness and consistency. Completeness means when you create a data, there you take a map and then they scan it and then start digitizing it. So when you digitize, you try to take probably you take a drainage network. So then you have orders, first order stream, second order, third order, fourth order, etc. So that means suppose you missed the fourth order, so that becomes you have only up to third order. So that means you are not completely done. So if you do completely, so then it should exactly match with the original data set. So that's why completeness is something you have to take care, and then if you are not taken care, instead of adding all the things, you are end up only adding only few things. So suppose you have to draw 200 polygons, instead of that you draw only 150 polygons. So that means only 75% of your data is added. So another important is the consistency. This consistency you can talk in terms of how the data is organized. When you take a vector data, so whether when you say road network, all the roads are properly connected and topologically built and establishing the relationship between these lines, or when you talk about area features, land use, land cover, are there consistency in the data? Some points are not added, some points are overlaid again and again. So there is spurious polygons are formed. So all these things we have to take into consideration. So that talks about consistency. Another thing is completeness. So data are the result of the production process, and the manner in which these process is performed clearly affects the data quality. So that is what about we are talking about data quality. So then when you talk about data quality, so there are many components are there. See, data quality, as I mentioned, some of the things already came there. You have a locational accuracy, like we talked about GPS, and then you can also talk about a attribute accuracy. Whether all the attributes are added or 90% of attributes are added. Even the attributes are added instead of taking the local name, and the name you might be adopting from the international level, so that may not match exactly with the local name. So those things also you have to consider. Another is temporal accuracy. In the time bound, how this accuracy changes. Suppose I digitize a cadastral map of a city in 2005, and then now I am using that map for checking on the ground. So that means in 2005 you are taking a city map with the plot details of each plot, and then now I am going to the 2009 again, I am going to ground and then check it. So is it correct? So because whatever you used earlier, it is a temporal. Earlier whatever used is the old data, and then the information belongs to that. So now I wanted to use after 5 years. How relevance is that? So that means temporal component has to be taken care. Another is lineage. Lineage is something like historical things, history of the data, when it is generated, how it is done, and what is the metadata, how it is it can be used for the present. In the present is I am talking about 1:4,000, 1:1,000 scale map, and whereas you are taking earlier data of maybe 50,000, which is not much used. So all those things you have to take into consideration. So completeness, as I mentioned earlier, completeness is something like which is complete in all the respects. That means in generating a data. When I talk a data, so I have generated a data with 90% requirement. So that means 90% of the data whatever you have created. Another thing is logical consistency. It is the organization of the data in different data structures, and maintaining the logical consistency between that, like left polygon, right polygon, and connected all these nodes, etc. And then what are the errors we